Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad for 10th graders 2024, problem number 1. Let a be greater than 1 and let b be greater than 0. We wish to find the least possible m such that a plus b to the power of x is greater than or equal a to the power of x plus b for all x greater than or equal m. Here are my hints for this problem. First, let f of x be equal a plus b to the power of x minus a to the power of x minus b for all real numbers x. Notice that f of 1 is 0, and then, as it is very often the case, investigate the derivative of this function to show that our function is strictly increasing on the interval 0 infinity, and from there deduce the value of m. We'll give this problem a try. Alright, so as I suggested, let f of x be equal a plus b to the power of x minus a to the power of x minus b for any real number x. Let's notice two things. First thing, well, f of 1, what is f of 1? It's a plus b minus a minus b, so it's 0. Let's call this condition triangle. We'll use it later. Now let's investigate the derivative of our function. Well, f prime of x, what's the derivative of a plus b to the power of x? Well, it's a plus b to the power of x times natural log of a plus b minus a to the power of x natural log of a. Alright. Now, let's investigate when is this derivative 0. Notice that f prime of x is 0 happens if and only if a plus b to the power of x natural log of a plus b equals a to the power of x natural log of a, and this is equivalent to saying that a plus b over a to the power of x equals natural log of a minus natural log of a plus b. Sorry, not minus, but divided by. Is it right? Yes, it is. Alright. Now let's investigate the sign of this function. Notice that this function, this right hand side, is what is between 0 and 1. It's between 0 and 1. Why is that? Well, of course it's positive because we assume that a is strictly greater than 1, so it is positive, so this is positive. Well, and notice that natural log is increasing function, so this denominator is greater than the numerator, since b is greater than 0. And then also, let's see that this number right here, a plus b over a, this number is definitely from 1 to infinity, which means that x is negative. So there is exactly one real number x such that f prime of x is 0 and this number x is negative. It's negative. All right. So in other words, let's call this number, let x0 be this number. Well, now it's pretty easy to see that f is increasing, strictly increasing. On the interval x0 infinity. So f is also strictly increasing on the interval 0, infinity, because x0 is negative. Alright, and let's call this condition triangle, square rather. Notice that this means from condition which I marked triangle and condition which I marked square, from these two conditions, we see that for every x greater than or equal 1, f of x is greater than or equal 0, but also, and for every x which is less than 1, f of x is less than 0. Or maybe exact for any x between 0 and 1, but it suffices, and now we can safely say that m must be equal 1, which means that our value of m, which we seek, is 1. For every x greater than or equal 1, this equality is true, and at the same time, for smaller x's, well, we have reversed inequality, so m must be equal 1. And this closes our problem. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.